Okay, I want to start by saying thank you to Aerospike team here and all of you for this great opportunity to talk to you about what we're doing at Adobe. It's really an exciting journey where Adobe is going through some kind of transformations with respect to the experience business. Before I start getting much into this entire presentation, I want to just touch on one important aspect here that everybody knows Adobe for one reason or another, but most often what we know about Adobe is Photoshop, is Acrobat. I'm not talking about Creative Suite, I'm not talking about Photoshop, those kind of things. I am actually going to be talking about a part of the business that many of you may not be aware of, what we call the experience business itself. It's a very large business, consists of various different solutions, including things such as analytics, web personalization, programmatic advertising stack, content management system, data management platform, and several solutions that are actually part of Adobe's portfolio. And interestingly enough, all of you guys think you know Photoshop and Acrobat, but most likely you're being touched every day by these other solutions, because there are a large number of enterprise customers who are already using it. So today's presentation, as I'm thinking about, jumping a little too fast. What I'm going to be touching on is that this notion of edge computation, and what does this mean from Adobe's way of looking at the world. A specific use case that we want to talk about is profiles and edge data source. Many of you guys who have been exposed to the programmatic stack and come from the advertising ecosystem will think about profiles, but this gets into some deeper thinking about what profiles actually mean. Next part I will be actually touching on is how we started looking at Aerospike becoming our core edge data store, and some of the learnings and the architecture that we're using with respect to Aerospike. So let's start by firstly looking at how we look at the world in terms of the data sets that enterprises actually have and how they should be thinking about the user experience. So the word user experience, when I try to use, thinking is something like this. There are several different surfaces out there where there is an interaction that's happening with customers. An enterprise at all times is interacting with customers using maybe your iPad, maybe your phone, maybe your web device, maybe actually is a person-to-person interaction. These are all interactions, these are about experience, providing the best experience. Enterprises are interested in providing the best experience. And this thinking is about how do you get there. The key aspect of this is that you must have data about your customers. And this data, what we talk about, is a 360 view of the data. Data that is coming, okay, from different surfaces that is getting collected. Now, once you have the data that's coming in, you need to figure out how you want to kind of store this vast amounts of data coming in. Most often, all the enterprises today are thinking about cloud computing, processing data, which is ingestion processes, ETL processes, structuring, treating unstructured data sets. But once you have that, one of the newer trends that almost all enterprises are already embarked on is that data sciences is starting to lead the aspect of sensing the most salient information out of these data sets. So we are seeing more and more investments that are happening, and all these data scientists actually require really clean data sets. And that's really the one aspect of saying get the data, get it cleaned up, make it available, and make it available for the data scientist. Once you actually compute all this stuff from a data scientist, and Mikhail talked about it earlier too, that we have to kind of get through that, but eventually there is actually something to be done, the best experience to be delivered. That's where the edge starts coming into play. So what you're saying is that you take the data in, you're trying to do all the computations and processing on top of the data. Once you have that, next step is that how do you take this data, move it out to a place where I'm interacting with individual customers, providing the best possible experience. So that's the kind of way an enterprise needs to start looking at the world in terms of providing the experience business itself. Now talking about essentially, Adobe deals with very large enterprises today with respect to the experience business. One such customer is essentially a US car manufacturer. They're thinking about putting about 8.5 million cars on the road. These cars are going to be IoT enabled. Every car essentially starts becoming a connected car. A simple example of experience in a car would be that, hey, how do I provide in-dashboard suggestions to the user? Now these cars, as they start moving on the road, they're going to start generating data in gigabytes and gigabytes in a day. Easily gets into hundreds of petabytes of data coming in. This is the scale at which we need to start gearing towards saying the data is coming in at this scale. We need to figure out what to do with this data. And by the way, our decisioning horizons, as we will start looking at, in some cases are milliseconds, in some cases maybe a second at best. So you have to start looking at how to take this amount of data, start processing it, and start actually responding to it. So how we look at the world is that as you get this data coming in, for the computational aspects of experience business, which is delivering the experience, whether it's a personalization experience or it's a programmatic bid that is actually being submitted, the computation itself needs to start getting distributed. Now, all of you guys who have been doing specific things, I mean, let's take programmatic world or personalization world, people have already deployed their systems in multitude of data centers. This is more of a general purpose model saying that this can be an infrastructure that allows all these kinds of applications to be built. Where you're looking at the computing getting geo-distributed, the data needs to start moving where the experience is getting delivered. So that's the second aspect, that move the computing, move the data along with it. And next thing is that the latency and the throughput of the computation, that needs to be managed at the edges, okay? Let's start thinking about the edge computing itself and how we look at thinking about where does the edge computing actually stop and where does the human interactions actually start coming into play. So this particular scale, as you start looking at it, is kind of a continuum. You're looking at latency considerations starting with very low latency at one end and relatively high latencies. At the high latency, this could be human-to-human interactions that we're talking about. These could be something that is, we are looking at systems that are trying to discover from a given data set, whether those are actually signal extractions, modeling exercises, are we doing reporting and a BI, those kind of things, those fall into the discovery mode. The next thing that actually comes in is that we can actually take the data and start doing actioning on that one. And even further, more stringent tasks start getting into where things start getting really real time, okay, where you're doing activation on the edges. Now, the timelines here we're talking about is at the lowermost spectrum when you're talking latencies, the examples all of us know is that programmatic advertising is where we're looking at a few milliseconds is all you have to make a decision. But this is where also targeting, real-time targeting will be going in. You have real-time segmentations. You have personalization kind of experiences. Many of these examples, they all start fitting into what we are calling the real-time edge computational portion. So this entire spectrum, as we start looking at it, we're dividing that saying that there is some portion we call real-time, some portions start becoming near real-time, and some of that actually starts falling outside. The portion that we're calling real time here is what we're trying to say that this needs to start moving to what we call the edge computational systems. And the edge computational systems, as we just touched earlier, we are talking about moving the data, we're trying to moving the compute and make sure that latency and throughput is managed. Now let's start looking at saying overall system thinking. How we look at the Adobe's larger infrastructure and the system thinking. So just before we actually jump too much into this particular aspect, I want to firstly start by saying that Adobe itself, the experience business, has been created through several acquisitions. About 10 or 12 different major acquisitions have been done over the last 7 or 8 years. These acquisitions, as you start looking at it, everybody came with their own infrastructure. Now, everybody had their own technologies. Everybody had different ways of dealing with it. And everybody had different requirements also. The exercise that we launched within the last 2 years was to figure out how to unify all these things on a common platform. So that's the journey that we are actually talking about. And this is where this notion that we're talking about Adobe Cloud Platform and how that actually starts playing into this comes into play. And of course, I want to kind of also start getting that edge computation and how Aerospike comes in. I want to kind of get to there as we start advancing this story. So on the leftmost side, what we're talking about of this aspect is how the ingestion cycles actually come into play. Here, we are talking about the notion that there are several surfaces from which interactions are happening. Those are IoT devices, web devices, those are your phones. We are picking up signals coming out of this. Think about this as forming your sensory network. Okay? You are sensing what is happening in individual customers' life every single point in time. That's the sensory network you're trying to build, which is coming from the left-hand side. The data keeps on coming in. Volumes of this data are extremely large. This data set, as it starts coming in, you're talking about data collection in real time, sometimes batch. Some data sets are completely offline. You could be getting information coming out of stores. You're getting information coming out of offline transactions, e-commerce systems. Once this data comes in, internally we look at saying that some structuring exercise is needed. A semi-structured data is much better than completely unstructured data for many of the decisioning processes. This is where we look at actually an ETL ecosystem that converts the data into standardized formats. Now, we use the term XDM, which is Extensible Data Model. Extensible Data Model, just want to spend maybe just half a minute on that one. This is a model that we have proposed right now. It's open sourced. It's completely open Git repository where anybody can contribute. But we are trying to kind of push it forward as a common data model that experienced businesses can start leveraging, not just for Adobe purposes. The next portion becomes the most interesting part, saying that, okay, we got all this data, what do you do with this data? This is where the processing portions comes in. Processing portion could be related to warehouse, it could be related to BI, it could be related to profile, as we're going to get into the profile example going next. Once you have this, the rightmost side that we're talking about edge computing is the next layer that comes into play. You take all this data, start figuring out how to move the most salient portion out into the edges. And this is the edge computing portion that we've been spending a lot more time on. But before we go there, let's take one concrete example of this Adobe Cloud Platform architecture. And this is the use case that we're going to walk through in the rest of the presentation here. So this part of the slide talks about what we're calling unified profile. There's also another name that is getting used now, is that experience system of record. The notion of profile here is about collecting data and storing data about your customers in one single location. And this data set that we're talking about includes everything that you can think about, whether it is your historical CRM systems, those are your behavioral data sets that are getting collected, let's say from web analytics or the mobile analytics, or those are your impressions and clicks that are getting delivered out of programmatic environments. Those are maybe your chat sessions, okay, that actually were the interactions that were actually captured. All these data sets need to be kind of put together because enterprises need this data to start thinking about how to provide the best experience. Just take an example of that chat session. I may need that chat session just when a customer call comes in saying, I want to see what was going on in the previous chat session, so I can link it. So when I'm talking about it, I can be very intelligent. A simple use case that actually says that these data sets become extremely valuable. And where do you need these data sets? They are needed where the computation is. So it comes down to saying, how do you move this data from one place to other place? So this notion of unified profile actually ties in. If you look at the previous diagram versus this, extreme similarity exists. One side, you have ingestion cycle that's coming in, which is, again, all surfaces pulling in the data, going through ingestion, ETL cycles, and put together in one single repository. In this way of thinking about it, this profile, what we're calling unified profile, could be in several megabytes of data per one customer. Now, none of this data set, of course, those of you guys are actually aware of what this actually means is that there is no single identity that you can always rely on across all different surfaces. So identities themselves form a different kind of data set, which is graphs. And there is, of course, the requirements of being privacy and regulatory compliance. So these kind of systems are now getting built with privacy from the first principle from the day one, versus actually trying to coming back to the privacy and regulatory aspects at a later stage. Once you have all this data, that has to start moving, saying we're talking about this profile. There is also the discussion of profile that you will find coming in the worlds of programmatic advertising, the web personalization kind of system, the content management system. All of these guys need some kind of a profile. That profile, what we're calling the edge profile. Now that usually needs to be a lot smaller, and we will start looking at how that actually comes together. Now this is where when we start looking at the data coming in a profile, which is large data repository, large database, how does that move to the edges? How do we figure out the synchronization between the two ends? How do we make sure that the most relevant pieces of data are actually moving back and forth? Those are the problems that we're actually trying to solve with respect to this architecture now. So looking at the components itself. So diagrams that we looked at so far, we were talking about how the data in the central repository we call the hub gets constructed, which is this unified profile. Now we are trying to touch on saying that, okay, let's move to the edges. The word edge here refers to typically a data center. Today, Adobe is deployed across various different cloud environments. We have a hard data center. There are several dozen data centers that exist today, which are Azure as well as AWS. On the edge data centers, we're talking about what are the edge compute components that are required. And yesterday I was talking to another Bharat. He was just mentioning about some of these components are coming in the discussions in Aerospike also now. So first and foremost, what we look at is that in order to kind of have a data center, which is an edge, to kind of work on this experience part, we need an asynchronous communication bus. All of you guys are aware of this. Kafka gets used widely across the industry. We are just using simple Kafka deployments. Kafka deployments in a model which is a more hierarchical, federated model of various different clusters that are interconnected and cooperating to make sure that we can have very wide deployments of Kafka. The next layer actually gets down to saying is that, okay, I got one part of the I/O, which is my networking portion. Second part of the I/O is my data. That's the edge data store. Edge data store is this notion that the data that is coming from the profiles, I need to make sure that it is housed somewhere. So at the time of compute, okay, whether the decision is about ML and anomaly detection, I have the profile access. I have the data, or I have previously computed data models available to kind of look at, and I can respond to it. The layer above that actually gets down to saying that, okay, I've covered my I/O from network and the disk. Next thing is that how do I take care of the decisioning portion? So that's where the Zen framework actually comes into play. This is essentially the notion that we can start looking at taking the signals which are coming either on a contextual basis coming from, let's say, an HTTP call that is coming in, or information coming on the pipeline, or the database sitting in the profile repository on the edge data store, and how to make decisions on top of it. There is already some of the systems that are coming up in the internet, IFTTT systems, if you guys have looked at that. It's getting modeled more around what is called IFTTT. Those of you guys who are not aware of it, IFTTT is a very simple thing. If this, then that. That's a kind of a very simple thing that actually does. But it's a very powerful concept which allows you to do a serverless compute across any arbitrary set of signals. The another important part that we talked about is this data collection, which is really not related to first three pieces, but it's an important component. The data must come in order that we can respond to that. So these are the main components. The component we are going to be focusing more on actually is the edge data store, which is where we started looking at saying, we started looking at saying what was the situation internally when we started looking at building edge data store. The internal situation was that there were various incumbents, solutions already deployed. We had Cassandra installations, we had Edge-based installation. We also had in-memory Postgres installations of several terabytes for purpose of programmatic advertising. So we had several different stores that were trying to solve this problem one way or other. When we started looking at saying we need one common system that we're going to build, we started doing the evaluation portion. One of the important things that came out when we started looking at it was that, what do we need? We need essentially an object cache, okay, for very fast retrieval, which is a very low latency, and needs to withstand the throughput numbers. that actually the system requires. And I'll get into what throughputs and the scale that we need to kind of support today. We started doing the evaluation against Cassandra, Edgebase. Those are the kind of the main two ones that we looked at. Postgres pretty much didn't get consideration because it was getting too expensive. And Aerospike definitely was coming out head and shoulder above. And with respect to two important parameters that we're looking at, the latency at the 95th percentile and the throughput that it can sustain. So stable throughput, that was actually one of the important considerations. So those were the two things that we started looking at, and what we started building using this was that it's become essentially a simple key value store. In looking at an example that we're running through right now, which is profile, a profile can be looked at simply in object cache. A profile is an object, a key is essentially the identity, and we just store the entire profile. So that's the kind of the world that we're looking at, saying this is how the profile store starts coming into play. The system is itself, if you look at it from an architectural perspective, how it starts looking is that on one hand side here, on the right hand side, we're showing hub. Hub data through pipeline starts actually getting sent out to the edges, and on the edge we have these edge data stores based on Aerospike, and we are loading all the data in. And the data needs to start moving at the speed at which it's arriving in the hub, and the new computations that happen on top of that are continuously getting sent out. Looking at just the numbers, when we started off, actually, this was the kind of important scale that we were looking at, saying what scale we need to start supporting. So if you look at a look-back window of roughly 90 days for us, 60 to 90-day look-back window, about 10 petabytes of data today arrives. Okay? We were looking at saying, okay, this is the starting point of the look-back window we want to be supporting. Now, 10 petabytes of data, we did not want to say that entire data is going to be moved onto the edges. This 10 petabytes of data is all time series data that's coming in, which is behavioral data, as well as CRM data sets, etc. The step that actually becomes more important is that how to distill this data. Now, the exercise that typically gets used is that segmentation is one such thing. Computed attributes, derived attributes, modeling exercise that generates, let's say, propensity scores. These are essentially computed data sets, and we want to move those data sets actually onto the edges. So the original design essentially was that let's start moving data which is much smaller data than the original data set that comes in, but compute it, and as computation happens, you're literally generating signals saying this user was added to this segment at this point in time because a new event happened, which is a behavioral event. It instantly gets dispatched on the pipeline, and it starts showing up on the edges. Now that data set is 20 terabytes of data. Now looking at essentially what kind of transactions we were looking at happening on this data set. There were two main kind of characteristics we were looking at, workloads. One was simply read, and one was the read, modify, write. Now read, modify, write is our own making in the sense that we are storing data as an object cache. So naturally you have to read the entire object, change it, and save it. So that's a natural thing. Now this is our workload, and we're looking at roughly a 4:1 ratio between the reads versus read, modify, write cycles. And we needed roughly 4 to 5 million hits a second to be supported across the system. So this was the main expectations. The replication was another important thing that we're looking at, saying that what replication models are actually important for us. So there is a reactive versus proactive kind of replication we're looking at. There's a row level replication versus a table level replication. Now, out of this, we're using XDR, which is more of a proactive, and it actually gets used for programmatic purposes. But the rest of the portions of replications we had to build ourselves. And these are essentially get down to reactive models, which is one particular edge may say is a cache fault. I don't have it. And it's okay to respond with a better experience in the next click. But I will actually cache fault, pull out from another place, and populate my local cache. So that was actually the reactive model that we're talking about. Latency considerations here, 2 milliseconds at 95th percentile, and our payload we are looking at was 10K. In this case, payload means actually the size of the profile. Synchronization. So that was another part that we're looking at, saying that how does the synchronization itself start looking. So synchronization is between hub and the edges, and the edges and the edges. About 5-second latency was acceptable. Now this is based on the fact that these are geographically distributed. You're moving over the networks, so you're not going to get millisecond level latency in synchronization ever. And general model that is acceptable here is loose consistency absolutely works in these situations. Now let's start looking at how we are looking at scaling and deploying Aerospike within this edge infrastructure. There's a notion that we actually use internally, we call it the pod. So in this diagram, the three pieces that we actually show together, which is the pipeline symbol, you can actually look at the Kafka symbol, along with the two database symbols of Aerospike, that actually we call it the pod. What that actually indicates in this particular picture is that it talks about two edges. In general, it is about some arbitrary number of edges. But multiple edges form one single cluster. So cluster A is actually geographically distributed. We are not talking cluster in one single location, but going across, connected using pipeline, so that they can be actually fully synchronized with each other. And with that, one of the things we had to start to think about was that what is our tenancy model start looking like? Can we deploy just one cluster? And the answer is simply no, because the challenges we have is that you can have a large cluster in which I can deploy customers on it, and if you get a big fish, this is a noisy neighbor problem. They start creating too much churn for somebody else, and nobody wants to take the challenges of this nature. Second part actually comes in is that there are companies who will come in saying that we have regulatory requirements, and we don't want our data to be mixed with somebody else's data. So we had to start thinking about the tenancy model, saying we need to support a multitude of tenancy models. So tenancy models, so I'm saying simple multi-tenancy model to saying, okay, you have your dedicated cluster, or dedicated pod that we are building. And the word we're using pod is because it's a distributed cluster. That's along with the pipeline. So that's the reason we call it a pod. So in this example, when you're trying to show, you can have a large cluster where we have a large number of clusters which are all sharing it. And for a much bigger customer, we say, okay, you get two different clusters at the same time. One more actually of this part that we have to build internally is the system metadata kind of information. This is information about the edge data store itself. Is the configuration data, is the schema about the different tables, is replication, synchronization strategies that are getting used. All that data set needs to be also replicated. That's the system metadata. So overall, how we're looking at is that this is the architecture we're starting to deploy today on the edges. And important thing was that to kind of identify the tenancy models were going to be varied. And we could not go with just one tenancy model. Now start looking at saying that internally, how does this system start actually working? So left-hand side, again, I'm showing here hub. This is where we actually touched on earlier that it's about the profile. So this is where the profile actually gets constructed. If you start looking at how that profile construction business is working is that you have essentially some kind of an app that is continuously generating signals that are coming in. Those signals are going through pipeline, just like everybody else, and those actually land up into this Aerospike cluster that you're showing on the left-hand side. This is where the profile, what we call the master edge profile, is getting constructed. And it is constructed out of continuous arrival of signals, which is getting put in, and storage happens on that one. That data set becomes available for replication. The replication coordinator's job is actually taking that data, making it available for distribution, which means that it's simply putting that data on the pipeline. Pipeline essentially connects to all edges, which are all data centers. Each data center has a synchronization coordinator service that is already built. Its main job is that incoming messages that are coming with respect to changes happening to profile are simply picked up and stored in the profile. This coordination actually keeps on happening from not just the hub that is actually doing this. This could be happening because we are doing a batch ingestion. This could be happening because actually there is a data set that is coming in. Let's say I have a Dynamics connector and that is sending me data that is coming in. The data actually goes through the system, which is streaming ingestion, and the data moves through the pipeline and start updating edges. So those are the kind of things we're looking at. And once you get to the edge, this life starts looking very simple. We have one database, which is system data. The other part of the database that we have is the profile data itself, where all the information is. And from the application perspective, which are rightmost side here, they just have a key value store SDK that you're using. From them, it's magically synchronized as well as consistency managed between all locations. Okay? And we are not using the word consistency in the same way Srini was talking about. This is simply the loose consistency model that we are talking about here. And applications actually job simply becomes saying, how do we start using the key value store where profiles are becoming available in the latency consideration we mentioned earlier. Now, one of the other things that is actually I haven't mentioned yet is that how do we handle deployment? So today, when we started, there was much of a blend of mind, I would say, that we were thinking about all the deployment needs to be on the hard data centers or on the metal. That's how people would say it. We have been deploying quite a bit on the cloud. And yes, it gives a little, but it almost doesn't matter. The efficiencies you're getting with respect to deployment and many other things, elasticity you're getting are way more important than actually the little gain we could actually get out of it. The place we are still kind of working on figuring out, and this is not completed work, is how do we figure out deployment in this kind of a tenancy model where we can provision a sandbox for a developer, which is maybe a small sandbox, get him to start playing with it, as well as provision for customers who are coming in. Okay, how to scale it out elastically. So those are the kind of problems we're looking at in saying that how do we actually start handling it? And that's kind of the work that is still ongoing for us. Now this is kind of last slide, I'm just recapping. What we actually kind of looked at so far was that started looking at overall the Adobe Cloud Platform and its architecture, so the need for the experience business to kind of start doing these kind of things, where you have data coming from one place, ingestion, ETL, going through, processing the data, specific example of profile, and dispatching into the edges, and how Aerospike forms essentially the underlying infrastructure for storage of the data and actually meeting the edge computational requirements. I think I want to stop here at this point if you guys have any questions. Go ahead.
On your previous slide, you showed the replication with the Kafka.
Yeah.
You're trying to use native Aerospike replication.
We have examples of that also in place. The reason we actually do our own replication is that our replication requirements were actually different requirements actually existed, such as the reactive versus proactive thing. We needed row-level control. We needed actually table-level controls. And when we started, many of these things were not available. So we started building much of this infrastructure ourselves. And today, the additional benefit we are trying to kind of get out of this is that we are getting the message format by which we synchronize is an open format internally, and that's published. So what it also allows us that for external, our enterprise customers, if they want to send their information, they have a I/O gateway, which is a pipeline. They can simply start dumping the data in it, and it will start landing up getting replicated. So that was a consideration by which we had to kind of start looking at it. But if I were to look at the programmatic stack, that is relatively very bound, saying, hey, we just need the things to be replicated, where we use a complete built-in synchronization.
My question is about the business use cases that we are seeing around edge computing. I have worked for Akamai. So the case for CDF is very well established. So it is very well understood and multi-million dollars. So what's causing this movement to edge computing? Like what are we advanced to so that we should start seriously thinking about edge computing and ask it because we do our implementation.
Right. So edge computing is actually coming down to saying actually the personalized experience that needs to be delivered. If you look back at Akamai's starting point and how the content distribution network started coming in, it was essentially the asset distribution, asset being created with videos, those kind of things. How can I distribute it? How can I locate it closest to improve the experience? Yes. But now start thinking about saying that your creative that you're talking about is single creative you're delivering, which is JPEG. I want to think about JPEG not as a one single object, but it's a juxtaposition of various pieces. And each piece I'm going to select for your particular experience. Now it's a computational task. And that's what actually needs to start happening with respect to the edges. And in this presentation, I'm talking edges going only into the data center. But edges need to go way further beyond the data centers itself. because that's not where the thing ends. The journey is still ongoing to the next levels.
And do you see monetization potential for those experiences?
Yes, so in fact, monetization of this one, what we are actually finding from a studies perspective is that the businesses which are looking at experience actually being the first are seeing significant benefits with respect to the revenues. In fact, simple things, internal employee satisfaction goes up when the people start thinking about experience business and providing the best experience, because you feel proud of what you're trying to do. So that's the kind of thing that we see. So there are a lot of studies that are showing that experience business is actually very relevant.
Thank you.
Can you share some thoughts around what thought process went into deciding on Aerospike for the edge computing and store? And my second question is, did you look at Redis with Flash as an option?
Yes, so let me go through that. So when we started actually looking at Aerospike, that time there was not much built-in experience within the organization about Aerospike. So being a very large organization, there were a lot of internal strifes to figure out saying, hey, we're getting a new technology and there are the IT guards who need to start thinking about it, etc. But all that stuff, the most important thing we're looking at is that we had latency considerations and throughput considerations we had to manage, and we needed it to work at certain percentile number, like 95th percentile was agreed upon, saying this is where we need to go to. And with this particular thinking, we actually wrote benchmarking. Okay, there was a separate team that was actually just doing benchmarking of Cassandra, Edgebase, Redis was included with Flash. We went through almost all of them. The results, what we found was that in some situations, yes, you get benefits using some of these Redis-like systems. You will see some benefits coming in, but the most important thing was that we were looking at a 95th percentile, saying that can we get a stable characteristics of the system running? And that's where Aerospike was always showing better than almost all of the solutions. In fact, internally, we still have large deployments of Cassandra and Edgebase, which are happening on the edges. And they're slowly trying to kind of migrate over to Aerospike. And one of the reasoning there is the stable characteristics of the performance.
You were talking about some use consistency on 95%. So how did it conflict while you were deciding Aerospike? Because we can still live with Redis with some kind of consistency laws.
So yes. So when we actually were evaluating Aerospike, we were not necessarily looking at Aerospike to provide us the consistency that is needed. We were happy with the loose consistency models, because in this particular situation, signals need to travel across the networks, and we were looking at saying several seconds latency would be happening. So it was natural for us. So whether the 95th percentile stability that we needed, that was simply the performance benchmarking, saying if the profiles exist, can I pull it out within 2 milliseconds? And there were certain size requirements that we're looking at based on the large programmatic footprint we have, the footprint we have with respect to personalization. They needed certain profile sizes. So those were the considerations that were going into decision making.
So I would like to just get in touch with you after this session. I have some urgency around these edge computing use cases, and I have some relationship with Adobe already.
Sure, absolutely. And I also have my team members here and architects, so they can also help. The person who actually drives this whole edge, Nipun Nair, he's already here. So we can definitely talk more. Well, thank you guys. Thank you very much.